So this next 2, 3, and 4. Give an example of a quadratic equation in standard form. Explain what the equation can reveal without using a graphing calculator. So we basically just went over this. I'm going to give an example. You need to come up with your own. An equation in standard form is going to look something like 2x squared minus 5x plus 4, right? And what's it going to reveal? There's a couple things, but most importantly, it's going to reveal the y-intercept at 4, right? So it's also going to reveal concave up because this is positive, right? I want to point out that actually the concavity can be figured out from any form. Like if you look here, there's a negative number right there. So notice that C matched with graph 1, it was concave down. All of the other ones had positive, 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 so they were all concave up. So each form can show you something about the concavity, but only the standard form is going to have that y-intercept pop out. So an example of a quadratic equation in factored form, y equals x minus 2 and x plus 3, right? So this is factored form, right? And notice they say quadratic equation. Equations mean you better see an equal sign. So notice I'm not just writing the expression, I'm writing the equation with the y equals so that you would graph it. This creates the graph by putting it equal to y. So what does this reveal? So this reveals the x-intercepts. And how I figured out the x-intercepts, I set each factor equal to 0. I solve. So it reveals x-intercepts at x equals 2 and x equals negative 3. So if I graph that, I better expect something, a concave up graph with x-intercepts at 2 and negative 3. So you come up with your own factored form. Now give an example of a quadratic equation in vertex form. So you did this as an exit ticket one day. Y equals x minus 2. So we've got something in parentheses squared plus something on the outside, right? And so this is vertex form. It reveals the vertex is at, and remember we need to take the opposite of this, 2, and keep this the same, right? So you come up with your own vertex equation.